In this video, we'd like to find the limits using graphical representation, okay, namely the xy plane graph. So, in this limit, the first example here, we're asked to find the limit of the y function as the x approaches -2 from the right. So basically, plus sign means from the right. X approaches -2 from the right. So piece by piece, we find the target value of -2 for the x. This is precisely going to be this line. X is equal to -2 is this line. It's a vertical line where x is always going to be -2. So as we can see, this is where the function ends, precisely at -2 here with an open circle. Okay? And what this means that this value, the function value at x is equal to -2, is not actually defined, right? We don't know the function value at this -2, but we know the value of this function based on the value that it approaches, right? We know the approaching value. We know that it's approaching -2, right? Because the y at this corner, the y value is precisely -2. If you find the ordered pair representing this point, it will be -2, comma, -2. So, and this is precisely what from the right means. So you're starting with the x values that are greater than -2, and you're approaching from the right side until you stop at -2, and you want to see along the function what happens as you approach from the right side to the target value of -2. So you're approaching from the right side, meaning that you can follow along the curve represented by the function until you stop at -2 for the x. And where you stop will be the y value. And this is the concept of the limit, right? And the y value is going to be -2 there. All right, so we can put -2. Now, this one says find the limit value of the curve of the y as x approaches -1. And notice it doesn't say whether it's from the right or from the left. So let's find the target value of -1 for the x, and that's going to be precisely this line. So we're looking at this point because it's right at the corner, and part of this line, x is equal to -1. And we have to see, in order for this limit to exist, both limits must agree. The right-sided limit and the left-sided limits must agree for the -1 target value of x in order for the overall limit to exist. Because once again, it doesn't say is it from the right plus sign or is it from the left, the minus sign. Right? It's just the overall limit. So let's take a look at this. As we approach from the right along the function, we stop here because that's the target value of -1 for the x. As we approach from the left along the curve, we also stop at the same location. So it looks like the limits are both going to be the same, right? Because they wind up at the same place from the right side and from the left side. So thus x, when x is equal to -1, when x approaches -1, it's better to say, the overall limit exists, and it also agrees. Both right side and left side limit, they agree because they wind up at in the same place. And precisely the y value here is 1, even though the function is not technically defined there, but the limit value will be 1 because that's where everything is approaching on both sides. So the limit of the y function as x approaches -1 is 1. Okay? Now this one says x approaches 1/2 from the left. Because it's a minus sign there, it means from the left on the top there. So let's find the 1/2 first. 1/2 is going to be here. Now here's where you got to be careful. It says from the left, so that means we don't use this curve. We use this one. Because we're talking about from the left, right? From the smaller values of than 1/2 approaching until we hit the 1/2. So we're coming from this side to the right side. So we'll follow along this curve here and stop until we get x is equal to 1/2. And that's precisely where? Right here. And again, the open circle, closed circle doesn't matter. It just shows you where the function is defined. The function is defined precisely here for the x is equal to 1/2. Right? Not here, but it doesn't matter for the limit. It matters for the limit when you're talking about the overall limit like in the previous example, but here it's fine because it tells you to find only the left-sided limit, right? X approaches 1/2 from the left, so you're not worried that there's a jump and that these two are not in the same place. You're only talking about the left-sided limit. And the left-sided limit is such that the y value stops at 0, right? The x-axis. So we stop at 0. As x approaches 1/2 from the left, the y value, the limit of the y function is 0. The next one. We're saying x approaches 0 and doesn't specify from the right and left, so this is the overall limit, right? So x approaches 0. Now, as you can see, 0 is this x value, is precisely the y-axis. That's where the x value is always 0, right? So we have to look at this target value. And as you can see, if you approach from the left to it or from the right to it, they agree because everything is continuous here. There are no jumps, right, whatsoever. So it looks like it's a continuous line here. So that means the overall limit will exist and the values agree. So the overall limit is going to be 1, right, because that's precisely the y value at this point. So when x approaches 0, the limit of the y function is 1. Next one, the limit as the x approaches 1 from the right. Notice the plus sign. So x approaches 1 from the right. So 1 is this x value. So from the right means that we follow along from here until we stop at the x value of 1. And again, we're not worried about the fact that these two don't wind up in the same place, although they share the same x value, right? Because we're only talking about the right-sided limit, not the overall limit, right? So we're fine. So we can safely say that we can stop here because that's the target value for the x. From the right, we stop here. The y value is 0, right? Because we're at the x-axis. That's where the y value is 0. So the limit of the y function as x approaches 1 from the right is 0. The limit of the y function as x approaches 2 from the left. So let's find the 2 for the x. That's it, this line here. This is the value that we're going to be playing around with. And it says 2 from the left. A limit of the y function as x approaches from the left to the target value of 2. Right? So we follow along from here until we stop there. And we check what the y value is there. It's 1. Now the limit of 1/2 as x, the limit of the y function as x approaches 1/2 from the right. Notice the plus sign. 1/2 from the right. Let's find 1/2. This is precisely here. Now notice we already explored what the 1/2 was from the left before. It was 0, right? We used basically this part to study what happens when the x approached 1/2 from the left. But here we're approaching 1/2 from the right. So we're using this part now. Not this part, but this part. Because we're approaching 1/2 from the right side, from the greater values of the x. Right? So we start here and we stop there. And notice here the limit of the 1/2 from the right, the limit as x approaches 1/2 from the right will be -1 because that's the y value for that point. -1. And now notice something really cool. I didn't ask you this. We might as well try to find the limit as x approaches 1/2. What do you think the limit would be as x approached 1/2, the overall limit? We would have to see if both the limits, the left side and the right side limits for the 1/2 target value of the x would be the same. If they were not, the overall limit would not exist. Now, graphically, you know there's a jump. So you know the limit will not exist. The overall limit will not exist. The left-sided limit exists. The right-sided limit exists, like we just found. But the overall limit will not exist because the both-sided limits do not give you the same value. Now, using algebra, using the results we have, not just the visual representation, we see that there's a -1 for the right-sided limit. And there's a 0 for the left-sided limit, right? So 0 and -1 are not the same value. So therefore, the overall limit does not exist. I should put that in yellow. Does not exist. Okay. Good. So we know that. Now, the limit as x approaches 1 from the left. Let's find the 1. Now, we already talked about 1 from the right. Where was that? That was right here, right? 1 from the right. The right-sided limit for the target value of target x value of 1. However, here is the same target value of x, but from the left side. So we're starting from the smaller values of x, approaching to the 1 value of the x, right? So we're using this part here. So approaching 1, we stop there. That's where the x is equal to 1. The value is -2. So the left-sided limit there is -2. Now here we're asked to find the overall limit as x approaches 1, the overall limit of the y function. Now, visually, we know at x is equal to 1, there's a jump. So we right away know there's no way the limit will exist. The overall limit cannot exist because these two values for the y are different. One is at 0, the other one is at -2. To confirm that, the left-sided limit we just found was -2, and the right-sided limit was, let's see where that was right here, right? The right-sided limit as x approached 1. So that was 0. 0 and -2 are not the same value. So therefore, this answer does not exist. So I hope there were enough examples to show you how to locate limits graphically and to understand jumps and right and left-sided limits, etc. And thanks for watching, and I'll see you in the next video.